morning, everyone. Before starting the course, I am delighted to welcome each and every one of you to this exciting new course on mathematical methods which are required for economic analysis. My name is Dr. Abdul Aziz NP. I am working as an assistant professor in the Department of Economics, Aligarh Muslim University. I am thrilled to be your mathematics instructor for this course. I encourage you to approach this course with an open mind and willingness to engage with materials. Mathematics is not just about solving the problems. It's about developing your problem-solving skills, critical thinking, analytical and logical skills by creating a strong foundation in mathematics which are used for economics, commerce and other related disciplines. See, I know that many students with economics comes from non-mathematical background. And generally, everywhere, the basic mathematics is considered as one of the core paper in economics. These students find it difficult to integrate mathematics into their economic studies. So therefore, this course is actually framed for them starting with very basics of mathematics which are generally used in economics. In this course, we will explore the fundamental principles of mathematics like set and its operations, functions, and how to solve different types of equations, especially linear equation, simultaneous equation, and quadratic equations, and then we will go for linear algebra, that is matrix and its applications, and also the input-output analysis. The course also includes the optimizing techniques of linear programming, where we will discuss the graphical as well as simplex method for solving linear programming problems. See, after this course, hopefully I will also offer the second part of mathematical methods, which mainly includes differential and integral calculus, difference and differential equations. I am here to support you every step of the way, and I am excited to see the incredible progress each of you will make throughout this course. I request you to watch the classes regularly to ensure the consistency and continuity, which will help you to build a strong foundation in mathematics and understand various concepts. Do some regular practices that help you to strengthen your mathematical knowledge and develop your problem-solving skills, critical thinking, logical reasoning, and analytical skills. Approach this course very positively, and together we will work towards building a strong foundation in mathematics that will serve you not only in this course but also your future academic and professional endeavors. Yes, get ready to unlock the puzzles of mathematics and tackle the transformative learning experience. I wish you very all the best. Thank you. Once again, welcome you all. The first topic we will cover as a part of this course is the concept of set in mathematics, its types and basic operations, and the Venn diagram. See, the set theory plays a significant role in various fields including economics, and it provides a rigorous and formal foundation for reasoning and analytical purpose. See, in everyday life, we usually talk about the collection of objects of a particular kind. And these objects can be anything, such as it may be a number, it may be a letters, or it may be shapes, or even other sets. So consider very simple example of the members of Indian cricket team. It is a group or it is a collection that includes all the players currently as a part of Indian cricket team. So I can write here the team India is equal to Virat Kohli, Rohit Sharma, Bumrah, etc. We all are familiar with the name of Lionel Messi. He is not included in Indian cricket team since we all know he is a well-known footballer and also he is not from India as well. So the condition here in this group represents the Indian cricket team. Therefore, Messi is not part of this particular group. Take another example. The vowels in English alphabets, namely A, E, I, O, U. Here the rule is based on the letters of English alphabets and a letter is in this set if it is one of the vowel A, E, I, O or U. For instance, the letter A is in this particular group while B is not included because B is not a vowel. Similarly, consider another example of the odd natural numbers less than 10. That is 1, 3, 5, 7 and 9. The condition is very clear. Any natural number less than 10 that are not divisible by 2 belongs to this particular set. For instance, see 3 is in this particular set because it is an odd number and also it is less than 10. While 6 is not because it is an even number. Consider another example, that is the rivers of India. Here the rule is based upon the geographical location. A river is in this particular set if it flows within the geographical boundaries of India. For example, the river Ganga is in this particular group, while the river Nile is not because it is not located in India, it is in Egypt. So it is not part of this particular example, that is the rivers of India. Now, see here, in each of these examples, we are explained here, we have a well-defined collection of objects in the sense that we can definitely decide whether a given particular object belongs to a given collection or not. Thus, the basic definition of set shows that a set is a well-defined collection of objects. It is well-defined in the sense that there is a clear and specific rule or criteria to determine whether an object belongs to that set or not. See, this property ensures that the membership of an object in a set which is clearly determined. So the basic concepts of set theory was actually introduced by German mathematician Georg Cantor in the late 19th century. His work initially focused on the problems of trigonometric series, but eventually led him to formulate and develop the theory of sets. Sometimes the terms like, objects, elements, members, class, and collection of sets are used interchangeably. Now look at the notations for the sets. Sets are typically denoted by the capital letters such as A, B, C or X, Y, Z, like that. These letters actually represents the set as a whole and we are generally denoting by using the capital letters. Similarly, we have the notations for the elements as well. See, the individual elements of a set are expressed by using small letters such as A, B, C or X, Y, Z, etc. the letters represents the specific objects belongs to the set. If consider an example, that is, if an element, for example say A, is a member of a set A, or we can say that the A belongs to set A, which is generally denoted by, see, A belongs to A. The symbol epsilon is used to represents, it is belongs to. The element A belongs to set A. So therefore, the element A, which we are generally reading, A belongs to A, or we can also say that the A belongs to set A. Similarly, consider element B. If an element B is not a member of set A, then it is generally denoted by B is not element of A. That means B is not element of set A. So the symbol here, this one, it is used to represent does not belongs to. It is does not belongs to. So here B does not belongs to set A. So therefore we can say that it is B does not belongs to set A. I hope you are clear about the concept of set and its various notations. Now, we are going to consider the methods for representing a particular set. There are two methods for representing a set. You can represent either in the form of a roster or tabular form, and the second one is set builder form. We will consider what are these types of representation. See, the first one is roster or tabular form. In a roster form, see, all the elements of a set are listed separately. That is, listing all the elements of a set within a curly braces, or each elements are separated by a particular comma. So we will list here each and every elements explicitly within the braces and separated by a particular comma. For example, see, set of vowels in English alphabets. See, the set of vowels in English alphabets in roster form, we can count it is A, E, I, O, U. And this set includes the letters A, E, I, O, U. We can write it is set A is equal to A, E, I, O, U. In this way, we can write in a particular set in a roster form. From this example, we can say that A is the element of A, or we can read it A belongs to set A, because A is the one of the element in the set A, which is also one of the vowel in English alphabets. However, B is not element of set A. We can write B does not belongs to set A. B does not belongs to set A because B is not included in the given set A. That is, B is a consonant in English and not a vowel. Similarly, we are going to consider another example, that is the set of even positive integers less than 7. In roster form, the set is written as, see, B is equal to, it is 2, 4, 6. It represents the collection of even positive integers less than 7, which includes 2, 4 and 6. So here we can write it is B is equal to 2, 4 and 6. So thus we can say that in a roster form is a convenient and concise way to represent a finite set, where each element is explicitly listed, because it provides a straightforward and easy to understand the representation of members of a set. The roster notation is especially beneficial and practical when we are dealing with the set that have relatively small and manageable number of elements. However, the larger sets or sets with large number of elements, then roster form is not practical to denote. Writing down each and every elements of a set in a roster form for a larger set can consume significant amount of space and may also lack the clarity or create a confusions. So similarly, reading and comprehending a large set listed in a roster form can be a challenging task. So accordingly, it may be difficult to quickly identify the pattern and also the relationships or specific elements in a method which is known as. So accordingly, it may be difficult to quickly identify the pattern, relationships, or specific elements in such a representation. So rather than using the roster or tabular form, in that particular case, that is whenever we have a larger sets, we can use another method which is popularly known as set builder notation, or descriptive statement might be more practical. So we are going to consider the second method of representation of sets, that is set builder form. So the set builder notation is actually a straightforward way to represent a set by specifying a common property or describing the characteristics that all of its elements shares. So consider our previous example of a set of vowels in English alphabets. We can denote V is equal to, or V is the set of all X, such that X is the vowels in English alphabets. See here, the symbol X, which is representing a generic element in a set. The other symbols like Y or Z can also be used. In between X, we used a colon. Read it is such that. And it specifies the property that each element must satisfy. So it is the property which is actually specifying by using the colon. So in our example, the property is a vowel in English alphabets. So X is a vowel in English alphabets. So then enclosed with the braces or the bracket which we are putting here, indicating that we have a defining a particular set. So in a set builder notation, we can write V is the set of all X such that X is the vowels in English alphabets. Similarly, we can consider another example of odd natural numbers less than 10. By using the set builder notation, we can write it is A is the set of all elements of X such that X is the odd natural numbers less than 10. So by explaining the property or by writing the property, we can represent a particular set which is popularly known as set builder form. Now we are going to consider the order and repetition of elements. See, it is important to note that the set are unordered collection of distinct elements. These are defined by their elements, and the arrangements or the repetition of those elements does not affect the set itself. It means that the way you list the elements or the arrangements of elements within the set does not matter. For example, set A is equal to 1, 2, 3 and set B is equal to 3, 2, 1. Both are considered as an identical because they have same elements, and the order in which the elements are written does not affect the sets. Here 1, 2, 3 and 3, 2, 1 both are the same. I hope it is clear to you. Similarly, if you attempt to include a repeated elements in a set, it is still considered only once. For instance, we have a set A is equal to 1, 2, 2, 3, which is equivalent to the set B, that is 1, 2, 3. As the repeated occurrence of 2 is not counted separately, here we will count 2 only once. So in that sense, we can say that it is 1, 2, 3 is equivalent to set B, that is also equal to 1, 2, 3. I hope it is clear to you. Now, I have given some practice questions here based on my lecture. I will solve 2 or 3 questions here and remaining question you try to solve yourself. If you solve more examples, I hope you will be in a position to become an expert of this particular topic. See here, we want to write the following examples using both roster and set builder form. Consider one example, first one, that is first 10 even natural numbers. How can we write this one in the form of roster and set builder form? See, in the roster form, we can write all the first even natural numbers, that is 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So in this way, we can write separately by using the commas. You can separate the elements and accordingly you can write this particular statement in the form of a roster notation. Similarly, you can also write the same by using the set builder notation. Here, set A is the set of all x such that x is the even natural numbers where x is less than or equal to 20 and greater than 0. Similarly, we have another example, that is set of colors in a rainbow. See, we can write it in a roster notation, that is here we know the set of colors in the rainbow that are red, orange, yellow, green, blue, indigo and violet. So in this way, that is in roster format, that is set B is equal to red, orange, yellow, green, blue, indigo and violet. In set builder form, we can write it set B is the set of all elements of x such that x is the colors in a rainbow. Consider one more example, that is set of days of a week. In a roster form, we can write it, that is C is equal to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, because these are the set of days of a week. By using the set builder notation, you can write set C is the set of all x such that x is the days of a week. So in this way, you can write both roster notation as well as in the set builder notation. Now similarly, I have given here many examples and you want to write these examples using both roster and set builder form. The first one, that is multiples of 4 between 10 and 30. So you have to write all these elements by using roster as well as in set builder form. Second one, set of months in a year that has 30 days. Third one, the numbers 3, 6, 9, 12 and 15. The fourth one, set of continents. The fifth one, the letters in mathematics. So you have to write both in the roster as well as in the set builder form. Similarly, some more practical examples are given here and you want to write in a roster form. See, the first one, set C is the set of all x such that x is the all even integers within the range of x where x is greater than or equal to -8 and strictly it is less than 10. The another one, set D is the set of all x such that x is the all prime numbers within the range of x where x is strictly greater than 10 and less than or equal to 20. The third one, that is set E is equal to, is the set of all elements of x such that x is the multiples of 5 where x is greater than or equal to -15 and less than or equal to +15. We have the fourth one, that is set F is the set of all elements of x such that x is the consonant letters in English alphabets. And the last one, that is set B is the set of all integers such that x is strictly greater than 4 and less than or equal to 12. You want to write all these in the form of a roster form. All these are given in the set builder form and you want to rewrite in the form of a roster form. Now we are going to consider the applications of set theory in economics. See, actually, the set theory provides a formal framework for defining and representing various economic relationships. Many of economic variables and their interactions can be represented as a sets, helping the economic students and the scholars to create the model accurately reflecting the dynamics of economic system. See, the economic space such as space of goods and services or the preferences all can be conceptualized by using these sets. And we can represent the economic agents like consumers, producers, and also the goods and services. For example, we have a set of consumers or set of producers and set of commodities. The relationship between these sets such as the preferences, production possibilities can be represented by using set notations. So these sets, these collection of elements provide a structured way to analyze, categorize, and understand the relationship between the objects. See, in economics, we always talk about the concept of demand and supply and how eventually these two opposing forces, that is demand and supply, reaches an equilibrium position. See, these equilibrium conditions can be expressed by using these sets. For example, in a market equilibrium, we have a set of price and quantities, that is P and Q, at which the supply and the demand are equal and which is defined as the equilibrium set. And at every point in the demand curve, see, at any point on the demand curve, we can say that we have different combinations of the price and quantity demanded of a particular commodity. Similarly, at every point on the supply curve, we have various combinations of the price and quantity of commodity which is supplied. And all these pairs or the combinations can be expressed by using a particular set. Similar to the demand and supply theory, the set theory have several applications in economics. So thus to conclude here, we can say that set is a well-defined collection of objects in the sense that we can definitely decide whether a particular given object belongs to a given collection or not. So we can arrange these collection or objects either in the form of roster or you can also represent by using set builder format depending upon the number of elements in a given set and as per your convenience as well. In the next lecture, we will discuss various types of sets and see you in the next lecture. Thank you.